Okay, tape 10 is on solving linear equations where there are two equations with two unknowns. So now let's look at the first problem in the notes. And this is considered to be what's called the addition method. Some people, some textbooks call it the addition and or subtraction method, but we'll just do the addition method on each one. Now, what we have is two equations with two unknowns, and we're going to try to solve for what set of numbers will make this work and this one work at the same time. For instance, if I use 2 plus 2, that would work. But if I put 2 here and 2 here, it would not equal to 5. All right, if I tried 1 and 3, if I put 1 and 3, that works. If I put 1 and 3, that works. If I put 3 and 1, that works, but this one doesn't work. What I'm trying to say is we're trying to find a solution set, a set of a number for x and a number for y that works in both equations at the same time. Now, to do this mechanically, instead of having to come up here and guess at numbers, to do this mechanically, here's what we want to do. What we want to do is to add these two equations such that one of the letters will drop out. We're going to add these two equations such that one of the letters would drop out. For instance, if I multiply the top one by a minus 2, and a minus 2 here times a minus 2 here, and added them, the x's would drop out. Or, if I multiplied this one by a minus 1 here, and a minus 1 here, and a minus 1 here, and added them, then the y's would drop out. So that's what we're going to do. So here's what we'll do. We will copy down equation 1 and leave it like it is. And then we'll copy down equation 2, but we'll multiply it by a minus 1. So minus 1 times this is a minus 2x, and a minus 1 times this is a minus y, and a minus 1 times this is a minus 5. And now if we add them, that's why we call this the addition method. So if we add them now, the y's drop out, and we have a minus x is equal to a minus 1. And now we divide both sides by minus 1, and we get x equals to 1. Now, don't forget that we're trying to find both x and y. So to find y, we copy down one of the original equations. And never use any of these. Use one of the original equations. So what we'll have is the first equation was x plus y equals 4. So we'll now take this number and put it where the x is and move it across, and we get y equals 3. Now pay attention, because here's what you need to understand. That means the solution set is the ordered pair of numbers x is equal to 1, y is equal to 3. That is a solution set, so we must check our work. Now, when you're working problems, you should come down in the last step, write something like that. And what we must do, though, is to go back and check to see if that is a solution set of both equations. So let's go back to the original equations and see if 1, 3 works in there. So you put a 1 here, you put a 3 here, and it checks. You put a 1 here, 2 times 1 is 2, put a 3 here, and it checks. So then 1, 3 is a solution set. Another way of working the problem, and I just want you to know this, it's not that you really have to use it, but another way of working the problem is to graph it. So what we'll do is use our, if you've looked at tape 9 or know how to graph, we'll look at that. Now if I'm going to graph x plus y equals 4, Put your hand over the y, and that says x equals 4. So 1, 2, 3, 4. Put your hand over the x, and y is 4. So it's 1, 2, 3, 4. And so we draw the line between those. Use a straight edge to do the way I do it. Then we look at the second equation. 2x plus y is equal to 5. Put your hand over the y, and x is 2.5, dividing the 2 to the 5, so that's 2.5. Putting your hand over the x part, y is 5, so y is 5. And you draw that line. And where they intersect, if this is drawn correctly, where they intersect, x will be 1, y will be 3. What we're finding then is this. This is the equation, x plus y equals 4. All of these dots, different x's and y's, add up to 4. All the points on this line, the x and y values, add up to 5. What we're looking for is the point that's in both lines, and that is the point x is 1, y is 3. So this is a solution set of these two equations because it's where the two lines intersect. It's the point in common to both lines. All right, let's look at now example 2. The second problem in your notes. All right, here we have 3x minus y equals 11, 2x plus 5y equals 13. Now what way could we get these to have one of the letters drop out? Well, we already have a plus and a minus here. So one way of doing that is if I just multiply this by 5, then that would drop out if I added them. So let's do that. Let's take equation 1 and multiply it by 5. So that's 15x minus 5y is equal to 55. All right, just writing the second equation down, that gives us 2x plus 5y is equal to 13. And now adding, we get 17x is equal to 68. Dividing both sides by 17, we get x is equal to 4. All right, now how do we find y? Well, we go take the first equation. You can use a second one, but just take the first equation, put the 4 where the x is, and go solve that. So this is 12. Move the 12 across. You get minus y is equal to minus 1. Therefore, y is equal to 1. Therefore, the solution set is x is equal to 4, y is equal to 1. All right, let's look at the next example now. Okay, the next example. 4x plus 3y equals 5, and 3x plus 2y equals 4. What letter do we want to get rid of? Well, here it really doesn't make any difference. They're all different numbers. They're not a plus and a minus, so what we have to do is make it work. So one way of doing it would be, let's get rid of the x's. So that means we're going to take equation 1 and multiply it by minus 3 or plus 3. Doesn't make any difference. Let's say we're going to make this one the plus 3. So in other words, what we're going to do is multiply the top one by this number and the bottom one by the top number. We're just going to switch places. So multiplying this by 3, we get 12x. By 3, we get plus 9y. By 3, we get 15. Now we'll multiply the bottom one by the minus 4. We could have multiplied this by the minus and made this the plus 4. Doesn't make any difference, just as long as you get rid of one of the letters. So multiplying by minus 4 is a minus 12, minus 8, and a minus 16. Now don't forget to multiply everything. Don't forget to multiply everything. One of the most common mistakes that we all make is we forget to multiply this side by the number. Okay, now if we add, these drop out, and we get plus y, and over here we get a minus 1. All right, so we now find what x is equal to. So we go back and take the original equation, 4x plus 3, put the minus 1 where the y is, and is equal to 5. This is what's called substituting. We're substituting what y is in place of y. All right, that gives us 4x minus 3 is equal to 5. It gives us 4x is equal to 8. So x is equal to 2, dividing both sides by 4. So our solution set is x is equal to 2, y is a minus 1. All right, now that we have that solution set, let's go back and see and check to see if it works. So going back up here, let's look at the original equation. Looking at the original equations, both of them now, must work in both of them. So what we'll do is go back and put the 2 where the x is, minus 1 where the y is, and see if it checks. Now we must do this in both equations. 4 times 2 is 8, plus a minus 3, that checks. This is 6, minus 2, that checks. Now don't forget to check it in both. But here's the reason. If you substitute it in one and get that answer, it will certainly should work in that same one. So you really better check it in the other one. In other words, what I'm saying is this. If you go find your second letter using this equation, then check your answer in the other equation. And if it works in this one, then you can be assured, fairly sure, that you did it correctly. All right, let's look now at the fourth problem. Okay, 4x plus 3y equals 15, 2x minus 5y equals 1. All right, which way we want to work this one? Well, it really doesn't make any difference. For instance, I could just multiply this by minus 2 and I could already have the numbers. Or I could come up here and multiply the top one by 5, the bottom by 3, and add. What I'm saying is it's not that big a deal as long as you pick out one way and do it. What I'm going to do in the notes then is do it by getting rid of the x's. So I'm going to write down the first equation, and then the second equation I'm going to multiply by a minus 2. Now the reason I did this is you're really better off if you only do one equation, because when you start multiplying two equations, that just increases your chance for mistakes. But again, do not forget that you multiply everything by the minus 2. Now adding, we get 13y. Over here we get 13, dividing both sides by 13, we get y equals 1. Okay, now that y is equal to 1, go back to the first equation, plug in by substitution what y is equal to, and we see that we get 4x is equal to 12, so x is equal to 3, dividing both sides by 4. Therefore, our solution set is 3, 1. Well, tell you what, let's do. Let's check this one by graphing. So let's go back and look at the original problem. And look at the graph of this. So here we go. Graphing 4x plus 3y is equal to 15. If you put your hand over the y, x is equal to almost 4. So we'll come over here and put 1, 2, 3, 4. Put your hand over the x, and y is equal to 5. So we come up here 1, 2, 3, 5, and draw the line. All right, the other equation is 2x minus 5y is equal to 1. If we put our hand over the y, x is a half. If we put our hand over the x, y is a minus 1/5. So that's right there. And so what we'll do is draw the line something like this. And where they intersect is the solution set. And sure enough, it's approximately 3 and up 1. Now all I'm saying is you can go sketch these or graph them real quickly sometimes, and just to see if your answer that you got the other way makes sense. That's just as good a solution check as plugging the numbers in. All right, let's look at example 5, problem 5. Now, problem 5 is kind of rearranged. So what we wanted to do is say, look, all you have to do is this. Just get everything over to one side. So we'll move the x across, leave the minus 3 over there, and we'll call it equation 1, and then we'll just copy down equation 2. And now we go back to the first 4 examples. All I'm saying is, whenever this thing is not arranged correctly, when the x and y's are not on the same side, just move them across and make them on the same side, and then go work the problem. So in this one, all we have to do is add, and we get 2y is equal to 2, dividing both sides by 2, y is equal to 1. And now we go back and plug that in. All right? So back in the first equation, we put the 1 where the y is. We got x minus 3. So moving the 3 across, we get x equals 4. So the solution set is x is 4, y is 1. All right, let's look at the next example, number 6. All right, here again. They're not arranged in the way we want to arrange them, so we'll make them work. So we'll copy the first one down. That's equation 1. Now equation 2, we're going to move this across. So that's going to be x minus 3y is equal to a minus 1. And now we're back to the first 4 examples. So let's see. Instead of having to multiply the top by 3 and the bottom by 4, all we have to do is multiply this one by 3. So we'll write the first equation down. And we're going to multiply the second equation by minus 3. So minus 3 plus 9 plus 3. Okay, and adding these, we get 13y is equal to 13. Dividing both sides by 13, we get y is equal to 1. All right, we go back and plug that in. Wait a minute. Now look. When you go plug in this time, plug it in your second equation, because you don't have to do any moving across. You got x equals to 3y, which is 1 minus 1. So therefore, x is equal to 2. So the solution set is x is equal to 2, y is equal to 1. Okay, now, what I'd like for you to see is another way of doing these. So let's look at the same problem and look at a second method. Instead of what's called the addition method, let's look at the problem starting from the beginning again and look at what is called the substitution method. Substitution method. And what it says is this. If you have something that says x is equal to, it already says x is equal to, then just like you checked your solution set, we can do the same thing. This says that x is equal to that, so we're going to go put that where x is in the other equation. So we'll come up here and put what x is equal to in the other equation. Plus 4y is equal to 10. And so this is 9y minus 3 times everything inside. 4y is equal to 10. Adding this, we get 13y minus 3 equals 10. 13y is equal to 13. Dividing both sides by 13, we get y equals 1. Same answer. But what I'm saying is that if you have an equation given somewhere in the problem that says y equals 2x plus 3, then you can just go take that and substitute it in the other equation for the letter y. All right, let's go back and look at number 5, the problem 5 example, and work it by what is called the substitution method. Now, I think the substitution method is a method you need to know about when they give you problems where one of them says y equals something or x equals something. All right, so looking at example 5 again, we have x plus y equals 5, but up here we have y equals. So what we'll do is go put that where the y is. So we have x plus x minus 3 equals 5, removing parentheses. Now let me take 2 steps in doing this. Removing parentheses will be x plus x minus 3 is equal to 5. So this gives us 2x minus 3 equals 5. Moving the 3 across, we get 2x is equal to 8. So x is equal to 4. Dividing. And so we get the same answer as we got before. Now this is the other method of doing this, and this is considered to be what is called the substitution method. Now, if I were you, I would stop the tape at this point and go work some of the sample problems at the back. Don't work them all, but work a few, and then continue with the tape. Okay, looking at problem number 7. Now let's see, if we multiply the first one up here, so we'll take equation 1, multiply it by minus 2, so we get a minus 4x plus 6y minus 12. All right, taking the second equation and just writing it down. And now we add. Well, we get 8y is equal to 0. Now, don't let things like this bother you, and don't jump to conclusions on stuff like this, but do it this way. To get rid of this 8 in front of the y, we have to divide both sides by the 8. So we divide by 8. We divide by 8. So we get y equals 0 divided by 8 is 0. Now, there's nothing wrong with that. Some students this will throw off because I'm going to show you some examples later in this tape where it really fouls you up when you get zeros. So all this says is y is 0. So go back in the original problem, 2x minus 3, put the 0 where the y is equal to 6. So this time 0 is 0, so we get 2x is equal to 6. So x is equal to 3. So the solution set is x is 3, y is 0. Now all that means is that the solution is on the x-axis. The solution is on the x-axis. In other words, graphically, it just means over here x is 1, 2, 3, 0. So these lines intersect on the x-axis. All right, let's look at the next example, number 8, problem 8. And here we have a problem with a bunch of zeros at the end. Again, work it the same way. Which letter do you want to get rid of? Well, we could write the top equation down and multiply the bottom one by 3. So that gives us 9x plus 3y is equal to 0. Adding, we get 11x is equal to 0. Dividing both sides by 11, we get x is equal to 0. Now go back and plug that in the original equation, and you'll find that y is equal to 0. So the solution set is 0, 0. What that means is that the two lines intersect at the origin. Well, let's go back and look at the original equations, and let's do this by graphing. Okay, original equations, we'll do it by graphing. All right, so here we sketch our x-y axis, and we do 2x minus 3y equals 0. Put your hand over the y, and what does that say x equal to? 0. Put your hand over the x, and what does that say y is equal to? 0. So this method doesn't work in all problems. All that gives us is one dot. So we better learn how to do this the other method. So what we'll do is come over here and make our little chart. When x is 0, y is 0. Now we have to make up a number for x. So let's let x be equal to 3. When x is equal to 3, that's 6. Move it across, be a minus 6. Divided by 3 is a plus 2. So another dot then is 1, 2, 3, up 1, 2. So now that's our line. All right, now if we graph the line 3x plus y equals 4. Okay, putting our hand over the y, x is equal to equals 0. Putting our hand over x, y is equal to 0. Same dot. All right, so we better make our chart here. All right, so we make a chart when x is 0, y is 0. When x is 1, y is a minus 3. So we come over here when x is 1, y is a minus 3. And so we draw that line. And look what happens. They intersect at the point 0, 0. All right, now let's look at the last two cases where we get some complications and problems involved in them. So looking at the problem number 9. All right, to get rid of one of those letters, we'll just multiply the top equation. Equation 1, we'll multiply it by minus 2. That gives us a minus 4x, a minus 6y equals a minus 12. Then writing the second equation down, we get 4x plus 6y is equal to plus 12. Adding, everything drops out. Now, the answer to this is many solutions. I don't think that you'll have this problem on a task test, but you might. You also will have it when you take algebra classes. Many solutions. Or another way of saying it is same line. And also in a college algebra class, they're going to call it by what's said as dependent equations. Now, what I want you to understand why there's many solutions and why we call it the same line is this. Let's go back and look at the original equations. Good. Now, what happens is this. When you get all zeros, everything drops out. What that says is any set of numbers up here that will work here will work here. Any set. For instance, let's say if I put a 3 here and a 0 here, that works. If I put a 3 here and a 0, that works. If I put a 0, 2, that works. 0, 2, that works. Other combinations would be what? If I put a 6 here and a minus 2 here, that works. If I put a 6 here, it's 24. Minus 2, minus 12, that works. So that's why it's called many solutions. There are many answers to this one, and whatever answers that answers the second one also. Now, the reason it's called the same line is for this. If you graph the first one, if you put your hand over the y on the first one, then x is equal to 3. If you put your hand over the x in the first one, y is equal to 2, and so you draw that line. Now, if you take the second equation, plot the same points, you get the same dots, you get the same dots, you get the same numbers on both lines. So when you graph them, what you're doing is just getting one line on top of the other one. So they're considered to be the same line. All right, let's take the last example, problem 10 in the set of notes, and look at what happens here. All right, so if we multiply the first equation by a minus 2, we get a minus 4x minus 6y is equal to minus 12. If we multiply the second equation just by 1, just leave it alone, 4x plus 6y is equal to 3. Now if we add this, all the letters drop out, but over here the numbers don't. Now that is not any kind of a correct answer. 0 cannot equal to a minus 9. So this is the case of having what is called no solution. No solution. There is not an answer to these problems. There's not a solution set. There's not a set of numbers, an x and y number that'll work both equations. Another thing we say is no solution are parallel lines. All right, let's now look at the same problem again. And see why it's no solution or parallel lines. If we were to graph this, if I put my hand over the y, x is equal to 3. If I put my hand over the x, y is equal to 2. All right, so I get that line. This is the 2x plus 3y is equal to 6. Now the second one, if I put my hand over the y, x is equal to 3/4. If I put my hand over the x, y is equal to half. So I draw that line and look what happens. They end up being parallel. There's not a dot. There's not an ordered pair. There's not a solution set on this equation that's on this equation. So therefore, it's considered to be no solution. All right, this concludes the work on solving linear equations where you have two equations and two unknowns. Again, what I would do if I were you is to finish and work all the example problems at the end of these notes to make sure you have your drill work down, and then look at your task booklet.